Hello, my name is Joseph Matthews with VTS, and I'm a regional sales manager for the Southeast US. And today I'll be talking about our casing design. So the industry standard for a 2-inch casing nowadays is typically a polyurethane foam insulation with an R value of 13. So kind of going back to that, typically when you hear polyurethane foam, what do you get? Usually it's an injected foam, and what's always a concern or some ideas that come to mind when you hear injected polyurethane foam. Usually everyone's always concerned with air bubbles or pockets within the casing. And why is this important? So typically at a 2-inch casing design with polyurethane foam, you're requested for an R13 value. That's usually what's spec'd. Where does this R13 value come from? Well, let's go back to thermal, right? The U value of polyurethane foam is roughly 6.5 per inch. So at your true 2 inches, that's where you hit your R13 value. But if you think about it, if you have these air pockets and these air bubbles, you're not really hitting your R13 value, right? And even your casing, it could actually not be meeting the spec at certain sections because of those pockets and bubbles. So going on those lines, why do those air pockets and those bubbles occur? Typically it's because of the manufacturing process. So you have your flat panel, the foam gets sprayed in there, and it rapidly grows to almost instantaneously fill that void. Now if that foam settles before the air escapes, that's where you get your air pockets and your bubbles forming within the casing. So how do we avoid that situation? This is actually a cross section of our polyurethane foam casing. And you can see here we have a uniform distribution of the insulation throughout. Now, how we achieve this is, again, through the manufacturing process. So instead of the injected foam process, we actually have a more automated process where we roll out our external and internal skins out onto a conveyor. We apply a thin layer of the polyurethane foam, and as it's going down the conveyor, we actually add in heat at certain stages. So we do a temperature-controlled process. This minimizes any bubble sizes, and when you think about it, if it's going down this like a conveyor, both the sides are completely open and ventilated to the air. So that's how we ensure that proper ventilation and then uniform distribution of the insulation throughout. First things first, so we achieve a uniform R value throughout the entire casing, that minimum R13 value. And the other thing is actually with the deflection of the panel. So again, as it's going down that conveyor and pretty much getting heat treated, it actually cures the foam and almost laminates the external and internal skins together. This really adds to the rigidity. So on a performance basis, we actually achieve a deflection ratio of L/300 at plus or minus 10 inches of static, where you typically see an industry standard being either L/200 or sometimes a bit stiffer at L/240. And most of the times this is tested at only plus or minus 8 inches of static. As you can see here, there's a coating that we apply to all of our units, and this is standard across the board, both indoor and outdoor. It's actually an alu zinc coating, which is pretty similar to your galvalumes, and what it does, it's a hot dip process, and it actually achieves a 2,000 hour salt spray resistance to each of our cabinets. So we at VTS, what are some key design features to our casing? Well, kind of how LEED focuses on the building envelope, we focus on the air handling unit envelope. And what I mean by that is we try to minimize any points where thermal or air leakage can occur within these units. So what do we do that's different? So as we talked about our casing design and our insulation, this is another point. To minimize any of this air leakage or potential for air leakage, we actually do a wraparound casing design with an internal framework. So in our smaller box sizes, from the AVS 8 to the AVS 40, we actually do a single piece wraparound construction. This means, we have no open seam here, same at the bottom. We only have 2 seams where the access doors are actually fastened onto the unit casing. And as we kind of go up in size, we go from the single C-shaped panel to 2 L panels that form a C, and with our largest units having 3 panels to combine to form that C shape. So another way we try to minimize any points where air leakage can occur on these units is actually with the access door. So if we take a closer look, As you can see, we actually provide a knife edge seal along the full perimeter of each of the access doors. And this fits into this ribbed gasketing, and that way we ensure, again, minimal points where air leakage can occur in this unit. And on the opposite end, showing the closing of the door, we actually see the compression of the gasketing on all 4 points.